Welcome to Maths and Science by IITian channel. In this, after giving a brief about the vectors, now we are really starting the physics as per the syllabus of IIT JEE and NEET. In this, first chapter is about the dimensions, units and dimensions. In this, I will take up one example today so that you will appreciate the importance of the dimensions and dimension theory and how to do the dimensional analysis. The question here is, what is the dimension of square root of 2m v0 into a square by h bar square? To find out the dimensions of this equation, we should know what each parameter in this equation means. The equation is, we'll proceed further. The equation is square root of 2m v0 into a square by h bar square, h slash, we can even call it as h cut, we can even call it as. Then what is it? What is this one? We heard of the Planck's constant h, but what is this h cut? What is the value of v0? And what is this a square? And what is this m? Because in the dimensional analysis, the quantities 2, 3, 4, these numbers, pi, those numbers will not be counted because we are finding the dimensions, not quantifying any physical parameter. Now, one by one we try to analyze. First one, m, we all know it is mass. What is the dimension of mass? It is kg. It is the unit, and dimension is m. And second one, V0 is equal to potential energy. You might have heard the name kinetic energy and potential energy. Kinetic energy and potential energy. Potential energy is represented by the capital letter V. V0 is the initial potential energy. Vi is the initial potential energy. Vf is the final potential energy. This is the potential energy. Then regarding the potential energy, what are the dimensions of potential energy? What is the definition of potential energy? I have already told you in the previous classes of my vectors. F dot S is equal to energy. F is in newtons. This is a scalar quantity. This has F, L. Displacement is having a dimension of L, and F has got the dimensions of F. We will find out the dimensions of F. F is equal to, as per Newton's second law, ma. M is mass into acceleration. What is acceleration? Meter per second square. That is m into L by t square. This m should be capital M, because when we are dealing with dimensions, we should write the capital letters. This is equal to, this we can write instead of m, mass into acceleration. When we are describing a definition, let it be like this. ml t to the power of minus 2. Then what is the energy? Energy is equal to FL, that is equal to ML T to the power of minus 2 into L. That means ML square T to the power of minus 2. That is the potential energy dimensions. And in this, what is A square? That's very important. A is the width. Don't confuse with area. Capital A is the area. A is the width. Then A square is equal to L square. L to the power of 2. Now, fourth one, very crucial one. What is H cut? This is called as the reduced form of Planck's constant. How it is reduced? And in which scale it is reduced? The reduced Planck constant, please remember, it is very, very important, being used in the modern physics, regularly used in the higher physics classes, BSc and MSc, and also your PhD or engineering. When you go into the engineering advanced classes, then you will get the reduced Planck constant. Reduced Planck constant is nothing but Planck constant by 2 pi. Please remember this. Reduced Planck constant is equal to Planck constant by 2 pi. Then what is Planck constant? You know very well a famous equation of energy. Energy E is equal to H nu. Please remember this equation. Very famous equation in modern physics. E is equal to H nu. Where E is the energy, nu is the frequency. What are the units of frequency? Frequency dimension is equal to 1 by T, that is per second. Please remember this. In simple one equation, how many dimensions we are getting? Frequency is 1 by T. And when you know the nu, when you know E already we have derived. Energy is equal to ml square T to the power of minus 2. Then what will be H? H is equal to E by nu. What is E? ml square into T to the power of minus 2 divided by 1 by T means T to the power of minus 1. This is equal to ml square into T to the power of minus 1. Planck's constant, Planck's constant, Planck's constant. Whether it is reduced, 2 pi does not have any dimensions. I have already told in the beginning. The numbers, the constants, they don't have any dimensions. Especially universal constants like 2 pi. It does not have any dimensions. But forget about the constants with dimensions. They are there. Gravitational constant. The constant acceleration due to gravity, it may be constant on the earth's surface. But still it has the dimensions. But the constant values like 2 pi, 1, 2, 3 numbers, square root of 2, they don't have any dimensions. Now, H cut is equal to H by 2 pi. That implies the dimensions of H cut are equal to the dimensions of H. The dimensions of H cut are same as the dimensions of H. What are the Planck constant dimensions? We have already found out. Planck constant is ml square t to the power of minus 1. We got all the dimensions required in the equation. Now what is the equation? Square root of 2m v naught a square by h cut square. That is equal to square root of 2 into m. M is the capital M is the dimension of mass. V naught. What is the potential energy dimension? ml square t to the power of minus 2. ml square t to the power of minus 2 divided by, what are the dimensions of h cut? ml square t to the power of minus 1. This h cut square, here it is h cut square into this a square is L square. Now let us simplify. This is equal to square root of 2, let us remove outside, some constant we can write m, and we need not write also in the dimensional analysis. We are only calculating the dimensions, not the constants. M square L square into L square into t to the power of minus 2 whole divided by m square L to the power of 4 t to the power of minus 2. That is square root of m square L to the power of 4 t to the power of minus 2 divided by m square L to the power of 4 into t to the power of minus 2. That is equal to square root of 1. That is some constant. That means m to the power of 0, L to the power of 0, t to the power of 0. The dimensions of the given equation 2m v naught a square by h cut square is equal to m to the power of 0, L to the power of 0, t to the power of 0. It is a dimensionless quantity. That means this particular value has no dimensions and it is used in finding the bound states, scattering lengths, in the modern and quantum physics. Hence, the answer for the above question is the given parameter or quantity is a dimensionless one. Parameter or quantity has no dimensions. The alternatives can be many kg meter square by second square. Then somebody may give kg meter temperature to the power of 4 second square C kg square meter to the power of -2. The units, people may give some units like this, answers as units, the units for the so and so. They can ask dimensions, they can ask units, whatever they ask. S to the power of -3, D, none of the above. The answer is none of the above. The answer is none of the above. It's a dimensionless quantity. It does not have any units, it does not have any dimensions. It's only a parameter applied in quantum mechanics or modern physics. With this, I want to stop this lecture. This is a jinx of the dimensional analysis, and I'll be proceeding with the dimensional analysis, and I'll be giving lectures on it and taking up some good examples like this so that you will understand the dimensional analysis and its importance. Thank you for listening to me. Best of luck to everybody. Please subscribe to my channel, Maths and Science by IITian. If you have any knowledge addition, value addition to your knowledge, please share, review, view, comment and subscribe to my channel. Thank you. Best of luck to everybody.